Okay, the doors are closed. I'm instructed that's when I can begin. So, hello everybody. My name's Shawn McCool. I snuck this slide in because I've become notorious for not introducing myself. So I'm going to try to avoid it this time. Let's see, I've been in web development for 20 years now, mostly PHP, some C#, Perl, stuff like that. I've run every job from turning recipes into HTML to web agency work, working in larger teams, smaller teams, some consultancy. And recently I've gotten into recording videos, stuff like that. So you might have seen some event sourcing stuff somewhere. Let's see, I was one of the early proponents of Laravel, and I created the original Laravel.io, the Laravel Podcast, Laracon EU, I don't know, various Laravel things. And yeah, that's enough about me. So, I don't know about you, but my experience over the course of my career has looked a lot like being really excited to do a good job, trying to learn as much as possible to iterate on what I knew and how I approached projects, only to end up either deploying code that my clients pointed out was broken, and then I looked and tried to decide, did this ever even work in the first place? Or, you know, maybe it was just the wrong thing, they didn't want it. So I've dedicated most of my career to figuring out why, despite all of my best intentions, I have a spotty record, right? So in this talk, I want to explore the current state of modeling insofar as Laravel development is kind of like idiomatic, the way that things are generally done in Laravel. And then, you know, some of the trade-offs of this approach, because not everything is perfect. Whenever we do anything, of course, there's going to be downsides. But we want to try to look at those downsides to soften them so that it's not such a struggle in the long term, right? And then we're actually going to use some of these ideas to develop features so that it's not just theory, there's source code. Now, at the bottom here, you can see that there's a link to source code. In that README, there is a list of the actual files that will be on the screen, so you may prefer to look at it that way. I personally hate source on slides, but I couldn't avoid it here. Maybe at the end we have time to talk. So first of all, just really quick, what is a model? Normally we think of a model as like a conceptual idea, like your understanding of something. And so usually it's like some kind of neural graph of various ideas, how they interconnect. And when we go and actually develop systems, we're taking our understanding of what should be done and we're translating that into an end product. It's not what, for example, the CEO or the CTO or the client wants that gets built. Ultimately, it's what's in the minds of the developers that gets built. Now, models are interesting because they're fundamentally reductions. And if you think about like something like a model car or a model train, you might have something specifically designed for a child to play with it. So it's a car, you can roll it around on the carpet. It serves its purpose by looking like a car, rolling around, and in this way, it's a reduction of the real thing. It's not an actual car. As a matter of fact, the reduction is a feature because if we tried to create a tiny little combustion engine and all of the working features, it would no longer serve as a good kid's toy. It would be too expensive and just ridiculous. But when we talk about models often, we're talking about ORM models. We're talking about what goes in that folder. In Laravel, it's Eloquent, often other times it's Doctrine, etc. And these are a different thing. These represent different things in different contexts. So in this case, Eloquent models represent database records. And not just database records of behavior. And I'll talk a little bit more about that. So the idea of the data model, fundamentally, is that we take all of the stuff we have to track and store in the state, and we put it into some kind of structure. Now, there's a lot of ways to structure that. We might think of the third normal form, for example, as a standard way to structure a data model. But really, a lot of this comes down to being fundamentally relational. So we might have a departments table, something like projects and employees, tasks, clocked time. And these tables are not just themselves without having fields, and these fields represent unique records. So we have the department, but the projects. But an interesting aspect about how we end up developing is we can refer to from one type of data to another through a foreign key. So we have the department ID, and we can refer up from one thing to another and create these interconnected relationships. Employees connects to department, blah, blah, blah. And this is the kind of stuff that we work with all the time, these deeply interconnected models. To put it into context, in like the 60s, they were building business information systems as well. But then the relational algebra hadn't been designed. We didn't have relational databases like MySQL. And so often what they use is a hierarchical model, where you'd have departments, but then it's spread out from there. And departments would own projects, which would have tasks. So you'd query down from the top all the way into tasks. Then if you wanted to find more about the employees that those tasks might be connected to, you would query all the way from departments into employees and find a way to combine and manage that. Now in like 1970, engineer IBM created the relational algebra, and from that we got the development model that we use today. And the advantage here is I don't have to go through departments. I could go to employees to get to tasks. I could go to projects to get to tasks, clock time up to projects. It's really one of the most important features of this is that I don't have to, I can start at any point. And that also, of course, brings downsides. Now, in the context of Laravel application development, so often our data model directly is reflected in the object model. So we might have these database tables, projects, employees, tasks, and those reflect up into the models, and they're generally given a singular name, and these represent records within these tables. So it's essentially like a mirror of the database. And that's our object model. But it doesn't actually always have to be that way. It's just the idiom within we're working. There's plenty of other ways to model. You could create an object model first, and then decide what needs to be persisted, and then turn that into a serialized form, which you then persist, and then rehydrate from, that's fine. But in this case, we're talking about Laravel, we're talking about Eloquent, and in actuality, yeah, we model our object model off of the data model. I would even argue that, so Eloquent is this exemplary form of ActiveRecord. It's basically the most featureful, modern, kept up-to-date ActiveRecord right now in PHP. And the idea is here that if we have these employees, we can query it back, and now I have the Stefano variable, and it refers to a record in that database, plus whatever behavior I have, of course, in that model. But Eloquent is also fundamentally relational. So you can do things like define tasks, and then just act like they're there. And it's going to go through and give you back what you want. And that's nice, that's fine. It's a good feature. But there are some negatives to this approach. For example, fundamentally we're leaking the schema of our database through the rest of our application. So if there's this field isAdmin, well, that field is maybe just a 0 or a 1 in a database somewhere. And if we look at our models folder, that's often a reflection of our database tables. If we have relationships, for example, maybe I have an images table, and I can point to it from any number of models, then that's reflected here as well. The fact that a user is related to this kind of image, and this image has a field URL, I mean, I feel like I'm just looking into the database at this point. Finally, Laravel has this feature that's fairly commonly used, where you just return a model, and it spits it out here. And this is a lot of times the way that people develop their APIs. So for better or worse, our APIs that bubble up into JavaScript or maybe even other people's systems are often direct reflections of our database structure and the content therein. So if we reflect on the schema leakage, we start with the data model. It bubbles up into the Eloquent model. Then from there, you can see the leakage in the controllers. And it finally makes it to our HTML templates and our API JavaScript type stuff. So what we have inside this data model is so deeply critical to the entire rest of the system. Now, really quick, I just want to go over how dependencies function, and I know this isn't new to you, but in this case, this class uses this trait. So I want to just point to this, my trait here, and say, if I try to compile my class and this trait doesn't exist, it won't work. It simply will not work, it won't function. However, if I try to remove this class, the trait's fine. It's not going to care. Now that's a beautiful relationship here. I would love to be able to remove stuff and not have it be a problem. Now here, my controller is going to return a response. If this response function changes in any way, if the name changes, if the order of the arguments change, if some argument changes, then suddenly there's a good chance that my controller is going to have a problem, because since it has to use this thing, since it interacts with it, it fundamentally has knowledge about it, and that knowledge is a really deeply negative thing when it comes to our desire to be able to change things and not negatively impact them. Obviously, a user extends model, we need that model. So why is coupling a problem? So this is a simple example from a Blade template. I have a blog post, and the post has an author, and the author has a name. There's two tables involved here, posts, authors, and I have this field name. Hidden is the idea that there's a author ID on the post table, so that there's the little subtle hidden dependencies here as well. So if I change this code's going to break. If I change author, this code's going to break. If I change post, the post, it's just, this code's going to break immediately. So if we want to make a change to how this is structured, we have to be able to track down all of these kind of instances and change them so that we know that everything's okay. And that might be fine in a lot of situations. But what we can do here is we can go from a task to an employee, then we can go from an employee to tasks backend, author, from article to author to profile photo, and in all kinds of directions. And it seems like this is entirely manageable for the most part. And that may be true if you have a small model or whatever. There's only 26 models here. Does anybody have an application with more than 26 models in production? I mean, right? That's kind of super normal. But it looks like a lot, and it's scary. And in reality, maybe I have too many lines. Maybe not. But I mean, how do you even go about refactoring this? Do you refactor it? When you go and need to implement a feature, do you say, what is the ideal form of this system? How do I migrate from this form to the ideal form? Or do you say, I can probably add a field over here, implement this feature right away? I mean, this is just kind of a consequence of the tools we're working with. It's expensive to migrate all that database stuff. It's expensive to migrate all this stuff. And while we might do it sometimes, it's my belief, from what I've seen, that a lot of teams will end up choosing to implement quickly the use case and then move on. And job well done, the company gets paid, everybody pays their rent, their kids don't go hungry. And that seems to be the primary measure for success. However, next time we're building on top of what we've made, and next time we're building on top of what we made, and ultimately we end up with these interrelated models that become incredibly difficult to modify without breaking them. So I have a couple strategies I want to talk about. This first is to isolate the schema leakage so that we can more easily modify the database without affecting the object model. And so here the database leaks upwards in this model here, but I can argue that maybe we can stop it here. Maybe we can stop at the Eloquent model. So if we have some really simple example here, and I just created this array so that we would even know what fields were on here. So maybe I want to list the user's worst fear. I'm directly accessing that attribute from the database. If I were to change that to a method, then I could pull from that attribute, and that gives me a point at which I can modify a single location, so that field can change. And it turns out that whenever you map one thing to another, those mappings are fundamentally boundaries through which you can translate from one thing to another. If I change this to something else, it's fine. This is maybe a bit of a academic example because it's not very interesting in the real world. But it does have the pros of your Eloquent models become more descriptive. You don't have to go to the migration to find out what fields you have to work with. You can choose what fields to expose. So maybe there's internalized some kind of state that you use for some internal purpose, but you don't want to expose that to things. You can make that decision to lock that within the model and not expose that to just any developer who is saying, okay, I'm accessing this now. You can change those database fields easily, and actually your tools can understand what's going on. So when you try to interact with a model, it's going to pop up, okay, here are the methods you can call, versus there is a magic array inside that we're not parsing, and we don't know what's inside there because we don't have a connection to the database, and that's really the only way to know. The negatives are, of course, there's more typing. That's always something that people really care about. This can be circumvented because you can directly access the fields anyway, and the models still ultimately represent database records. So really, I don't think this is the most compelling way to solve this problem of needing to go back and maintain systems without breaking things. But it does help to highlight that there is this bleed through of what we're designing in this bottom level, and actually in a lot of ways the normal way of designing these kind of apps is a very data-first, data-centric approach. So we're actually kind of embracing the idea that this database is the model of the application. So if we're trying to reduce the amount of struggle we have, we might have to look elsewhere. So a more compelling strategy might be just to reduce the scope of our models. So if you want to go and modify a part of your system, and maybe it's the first feature you add to a system, it's not going to be difficult. The first feature is a blissful, wonderful thing that doesn't really go wrong. And even if you build it, ship it, come back and edit it, it's effortless because all of the complexity can fit within your mind, more or less. And you don't run into the problems that modifying it destroys some other part of the system which you just didn't see coming. Really quick, how much do you believe in this feeling that when you modify something, you destroy something over here? I mean, does everybody have that experience? Because for a long time, I think that when I hear that, it sounds like a lie, like, oh, this is just silly. It doesn't really happen. But like in my experience, this is just like a regular thing. So it's interesting that you have that experience too. So what if we have this model, this interconnected graph, and in order to make it more manageable, we just start slicing it apart. So now it's not so interconnected. Now the connections are limited to, I don't know, isolation on some abstract variable. And there's a lot of ways to isolate components of models. You've seen where people namespace, for example, they'll have a namespace, for example, controllers, models, views, infrastructure, domain, service. You'll isolate by the types of constructs you're dealing with. But then there's, for example, the domain-driven design approach where you isolate by basically linguistic and logical boundaries. But to kind of highlight some ideas, I'd like to start isolating by features. Because when I go to work on an application, I'm either modifying a feature or adding a feature. That's basically it. So if I need to succeed at those things in my perspective, then I need to be able to deliver what I am intending and not have just spontaneous surprises that say, okay, despite all of my best intentions, I still have somehow failed here, and that's a painful thing emotionally. So maybe I have a couple features. These are just abstract at the moment, but what I do is I draw a very strong boundary between them, and I just say no communication. You can't know about each other, you can't talk to each other, nothing. And in this way, I get away with having various models, and they're all easy to edit. I mean, I can modify this and cut it apart, and of course it didn't affect anything else because, I mean, there's no relations to it. But without interaction, we don't actually have a functioning system. It's not interesting. Why should these things exist if not to interact with one another? So how can we resolve this? Well, we could communicate through fields. Each of these objects can look at each of the other objects' fields. We can make everything public, and we can observe like that. That may be the worst kind of coupling, but it's there. We can communicate that way. We can interact that way. Objects have methods. This is better, of course, because then we're kind of getting into the whole object-oriented paradigm. But still, if every object can just interact with any object's methods, then any of those change, we don't know how far down the rabbit hole things go, where the dependencies are. I mean, at best, you're just going through JetBrains and saying find usage and trying to isolate all of the places that these things pop up. So I'm going to propose a model for limiting coupling so that we still have some coupling, but it's isolated in a predictable manner, which is events. And Laravel has event functionality built in. Is anybody using Laravel event functionality? Okay, so it's pretty popular, right? Is it popular for this reason, because it limits coupling? Yeah. Okay, so imagine we have a couple isolated features, and we have to communicate between them. Well, we can just create an event in one of them. So as part of a feature, we identify that something occurred. So maybe, I don't know, I send an invoice, and then this invoice sending feature says, okay, invoice was sent. Now every single other feature can observe that. Now I'm not coupling to the models, the service classes, or anything like that. I'm only coupling to this event. So that if anything in the model changes, it's okay. I just have to be aware that when I modify that event, anything that consumes it might need to change too. So one feature might broadcast an event, and then any feature responds to it. This is kind of important. It's just anyone global. So for example, if I register a member is registered, then I want to send them a welcome email. I want to maybe preload their account with credit, like I'm DigitalOcean or something, and maybe update a GDPR log. Now, in these examples, we don't even know how the development team has isolated these 3 listeners into features. We don't know anything about that. All that we know is those functionality can be distributed amongst multiple feature sets that are isolated from one another. They can be all in the same, but they don't have to directly talk to each other. They don't have to know about each other. They just know about the event. Now, we're talking about reducing scope through boundaries. I would say the pros are that the features become small and simple enough that we can understand them. We can add new features without impacting others. We're less likely to break stuff when we modify things because we're very clear that communicating between features relies on that message sending, relies on those events crossing over those boundaries, so that when that communication needs to be modified, that's when we need to be extra careful and that's when we need to focus. But it's still easy because those events are listened to. So we can track down everywhere that those events are listened to relatively easy. And it makes it much simpler not to destroy stuff. And sometimes you can even delete an entire feature. So imagine a feature is sitting there, like I have invoice sending feature. Then I want to say I want to send late payment reminders. Maybe I create a new feature called late payment reminders, and I listen for when an invoice is sent. Then in that isolated feature, I track when it becomes overdue, when it becomes extremely overdue, and then I just check every day. Did this become overdue? If so, I update the model saying become overdue, and then I send an email. And then when it becomes extremely overdue, I send an extremely aggressive email. And if that's a feature that works. When the invoice is paid, that system can just drop that model. It doesn't have to know about it anymore. It can just listen to when an invoice is sent, listen to when an invoice is paid or written off or whatever. And if I drop that late payment reminder feature, who's to know? I mean, who's to care? Like, there's no other features that are reliant upon that in this example. So it would just fizzle out and be fine. In order to do this, you kind of have to understand dependency direction a little bit. And there's a little bit more of a requirement, but it's not always a bad thing. There's definitely more discipline required because you can still access all of the fields from the database on an ActiveRecord model from anywhere in the application. So this is entirely developer. It's in the construct of the development team's minds. It's a construct in their minds. So if you can get your team on board with it, great. You probably can if you have enough sway, but let's see here. Individual features require more state management. And this is a significant negative, and I'm going to develop a couple features in a minute, and you'll be able to see where I'm talking about here. But if you're isolating these models, then that means you're having to listen to these events that are being passed around, and then each feature has to manage its own state, whereas previously you would just have a big blob of state, and you would directly access whatever you wanted at that time. It's very tempting to just jump into that state and get what you need out of it. Ultimately, it doesn't fix everything, so maybe worth mentioning. So I think this is more of like a B class way of solving things. It's not great. It's not like S class or something where I just think, oh man, this is amazing. This is the next thing. But I think ultimately it's so long as we're starting to identify, okay, how boundaries can reduce the scope of our models and how we can communicate past it. That's really the important thing. So here I'm going to go through the development of something like 4 features. I'll start a little slow and then speed up towards the end. And again, the source code is available there, and the application is fully functioning. So if you're interested, you can check it out and download it and just run it. But I want to build a conference management app. This is an easy example because we're at a conference and because I manage conferences. So the first feature is user authentication. Then I want speakers to be able to submit their talk ideas. Organizers need to be able to approve talks, and then the talks will be scheduled. Now, when we're implementing user authentication, I think that a lot of times you build the authentication first because you just want to have something to work with. You want to know that the stuff you're doing is behind that gate, and it makes sense as a first model. So you have your user table and your user model, and this is how Laravel ships. This is the standard paradigm. And as you continue to build features, the user model becomes this magnet that pulls in a tremendous amount of state, behavior, and then all of a sudden, the user model becomes like a giant mess. And I think this is a really bad pattern. And when I say that, just keep in mind that if I feel like anything's not great, I have that opinion because I've done it for so long that I've made basically every mistake that I talk about here and more. So the user model is used everywhere, and as such, it collects any type of information needed for any features. So no matter what the feature is, if it seems like, okay, this belongs to the user, then it just ends up in this giant 40-column users table. Many features don't even care about most of those columns, most of that data. And have you ever had a users table with a type field, like admin or speaker or author or something like that? That's a horrible situation to be in, I feel. You start to design yourself into a box, and it really starts to become painful later. And it's so hard to separate that massive aggregate user model after it's gone that long. I feel like when we design systems in this way with these big, deeply connected models, and when we just slap a bunch of behavior into the user, it becomes almost not refactorable to the point where you just feel like, okay, I'm going to rewrite this. I'm going to get a budget, and we're going to get this team to rewrite it, and then 6 months later, you've built the same app. So let's implement our user authentication. We're going to start with the database table user authentication, and it's going to have email and password. Only email and password because we have decided that the act of authenticating a user is going to use this algorithm. We might use two-factor authentication. We might use sign-in through GitHub or any number of single sign-on solution. We could have them send a photo, and we just say, yep, that's you. There's any number of ways to authenticate a person is themselves. User authentication does not a specific person make. It just is a way of validating that indeed they are who they're supposed to be. So we're going to limit this to just email and password because that's the design we choose. Some password reset stuff. Then we end up with the ORM model user authentication. It's really simple. There's hardly anything here. For people who like source, this is just the migration. The important thing is here that there's just email and password. No names, nothing interesting like that. The user model I have, it just basically says, register this user, and it stores their email and password. So the summary of the feature is we can authenticate a user's identity, and we aren't pretending that this authentication feature is the feature that has additional interesting information. This is a user authentication feature. It's not like a blogging feature or something like that. It's just to determine a person is who they are supposed to be. Now we want to make sure that speakers can submit talks. So we'll start with a speakers database. And what I'm going to do here is I'm going to have a user ID, the name, contact email, and bio text. So the fun part about this is that I'm pointing to an authentication token, essentially. So that when somebody registers as a speaker, then I need to know, okay, what's their name? I can say, give me the speaker for the currently logged in user. And I get that back. And now that speaker model has the relevant data and behavior for this specific feature, for being a speaker, not for being a user, not for authentication, for specifically being a speaker. Talks are similar. We point to the speaker ID, not the user ID. And it's just arbitrary stuff. Again, we mirror the database into our models. And let's say we have a welcome controller. The welcome controller will allow you to log in or register. And then for talk submissions, you can submit a talk and you can view your talk. And that's basically our feature. When we submit that registration, when we say, I want to register myself as a speaker, I'm going to register their user authentication details, and then I'm going to make them a speaker in that order. So that registration process requires the user authentication details. Now, maybe in your design, you don't want that. You just want to have a database of speakers, and you want to be able to tack on user authentication if you want to. You would just model it differently. Boring code. Might be interesting that the table name I'm naming talk submission because that's the feature, and then speakers because that's the model within the feature. This is just lazy name spacing, basically. And whenever I need to get the speaker for a user, I can call speaker : for user, and then just pass in the currently authenticated user, and I get that speaker model right back. The speaker model can then be used to grab their talks or whatever relevant within that feature. Now, speakers can register. This new speaker model attracts speaker behavior. So because we're not using that user model, every time we need to add some new bit of data or something for that speaker, it's not going into that user model, it's going to a speaker model where its dedicated purpose is to represent the nature of a speaker. Speakers can submit talks, and talks are assigned to speakers, not users. Now, once you've submitted your talk, an organizer needs to come in and say, okay, who am I going to schedule? Which talks are going to make it, which talks are not going to make it? So we're going to start by implementing it with the database first, because that's how we think a lot of times. And now, in this case, we have organizers. The organizer, in this example, it's just a name, essentially. A name, and it points to an authentication token. Now, I can get away with this because what other discriminating factors do I need for this feature other than the organizer's name? I may want to say who approved this talk, and then I have a name, I have an organizer ID, whatever. So this is another one of those magnets for specific kind of behavior related to organizers, so it doesn't all fall onto some single model that can never be pulled apart again later. Now, I have a database table called submitted talks, where all the submitted talks might be. And that's a little different because now I don't have this concept of speakers. I just have title, description, the speaker's ID, the speaker's name, and a bunch of other fields. I kind of normalize this. It's no longer speakers and talks, and I refer to each other. I just say, in this feature, we think it's easy to just, boom, put all this in one thing, and then have the organizers review it like that. So your implementations can be feature specific. We mirror those into the ORM models, and then we have a controller approved talks where the organizer can log in, they can list all the talks, view individual talks, and approve the talk. Yep, migration. And here's all of these fields that can go into the talks table, since we don't feel like our development team at this time doesn't feel like we need a speakers table and a talks table. We just dump it all in here so that when we go and give that listing, we just dump it out from here. So we don't feel like we need the relationships or anything like that. If we want to add things, we can add them to here. And I mean, in the context of a large system, things like the third normal form and organizing the database in specific ways, you have specific values and trade-offs, but when you isolate these things down into really small bits of functionality, sometimes it's nice to have a lot less code and things just all in one place, and you have fewer negatives as a result. Now in the controller, I can just say, when I go to approve the talk, approve this talk, it's this ID, and this is the organizer who approved it. And I get the organizer by saying, give me the organizer for the user that's currently logged in. Now this feature, the organizer can view lists of talks, view individual talks, and approving a talk. But where do the talks come from? There's no place in this feature where the talks are coming from. That submitted talks table is just completely empty. We're not reaching into the other features database table and seeing what talks have been submitted by the speakers. We actually have these boundaries that we specifically don't want to try to cross. So again, we fall back to events and we say, how can we implement this by limiting the coupling from one feature to another? In here, I can raise a talk was submitted event, and in the talk approval feature, I can create an event listener called register submitted talk. So when the talk's submitted, I go to register the submitted talk, and the talk submission event looks a little bit like this. It's just a ton of fields. It's a ton of fields, a ton of getters, and all it serves is to be a vessel to transmit data from one to another. It's a schema, essentially. And this can have as many type hints as you want to. It could use primitives. It could, however your team decides to design it, this is the format for communicating from one feature to another. When I actually go and submit that talk, I do all the normal ActiveRecord. This is a database field on the left. This is the argument value on the right. But here I use Laravel's event system, and I say, raise this event. This talk was submitted. I just throw all of that data in there. And so every time I submit a talk, this event gets raised, and any listeners can hear it. And here's the listener. And it's just register submitted talk. All it does is listen to that event and add a record to the database table. Now, I know this seems super redundant, and this is the kind of thing, this is the kind of reason why we don't, why we like Eloquent in the first place. We can bypass all the need to type out fields, to do all these things. It's snappy. But what this does is, since we're remapping one thing into another, this is a boundary. If that event changes, I change this mapping, and it's okay. Every time I have a listener that listens to an event, I have a mapping, and at that mapping, that's where I make this switch. And this is easy to understand, and it's easy to find. You can even tack on an interface event listener. And so just look at all the event listeners in the whole system, say who's using this event. You can say, talk was submitted, find usages in JetBrains. And you'll find every single listener that uses this, and you just change these mappings, and that's done. And that's a really big advantage for example, when you are changing the fundamental nature in which multiple aspects of your application are coupled. If you change the other aspects of your system, it doesn't matter because they're not deeply coupled with everything else. Now, scheduling talks is just a very easy feature because we're super lazy. Talk was submitted. Those talks get registered for approval. When a talk's approved, they're just auto-scheduled into the first available slot. It's just event listener. And if you look at the squares here, rectangles, you see this layer of communication. Everything below that layer just almost doesn't matter, and that's kind of the beauty of this. You can modify anything, focus on the communication layer, and when you modify the communication layer, I mean, you focus on the communication layer, that's it. Now, when should we use these techniques? I don't know. So the point of this talk was more or less to talk about boundaries and to talk about coupling. And what you do with this, I don't know, because I mean, everything is so specific to your circumstances. I personally take this to an extreme, and I basically, in my systems, I focus on things like event sourcing and event-driven systems. And I'm really a big fan of communicating over these boundaries because it's so easy to change these things later or to add new features. And I feel like it allows me to focus in ways that, I think back to how I programmed 5 years ago, 10 years ago, and it just exhausts me. I'm just exhausted by myself. And I feel like that lack of energy, that emotional energy, that focus that's required to not ship bugs. Okay, now I'm making a note. I'm modifying this thing, so I need to go through the entire system and verify that anything that uses this is correctly checked. And making notes and just how hard it is to track. I think that's a big negative. We can say, let's just test everything really deeply. But there's an economy to tests. Not every test is equally valuable, and tests themselves come at a cost. So by reducing the need for as many tests, I think that we end up with smaller code bases. And if you can deliver value, if you can deliver products with small scoped features, with a smaller amount of code, a smaller code base, then I think that we're all a little bit happier at the end of the day. And that's all the time I have. So remember, the source code's here. Check it out if you're interested at all. The application's fully working. And thanks for your time.